Pretty much everything you do as a football data scientist has to, in the end, be communicated by pictures. Today, we're going to look at two of the most basic pictures in football. We're going to start by looking at shot maps, where shots are taken from. And then we're going to look a little bit at pass maps, where passes start and where they end. We're going to start with JSON files for match data. We looked at JSON files last time for competitions and leagues and so on. We're going to look inside event data for particular matches. We're going to find all the shots in the match. Then we're just going to look quickly at how you plot a pitch. Then we're going to plot the shots on the pitch. Then we're going to highlight the goals so you see specifically which were the goals and which were the shots. Then we're going to plot the expected goals. We're not actually going to calculate the expected goals this time, but I'm going to show you a way of plotting expected goals. We're going to make shot maps very like Michael Cayley puts up on Twitter. So he's done this for a long time. We're going to make an expected goal map that looks like that. And then finally, and this is going to be an exercise for you to do, we're going to look at how you can plot passes. So I brought the ant down here so you can see the ant while I'm talking. There we go. Right, let's have a look in Python then. The code for everything we're going to do today is in plot shots and passes. So you can download that from the GitHub site. If you don't remember how to do that, have a look at last time's lecture. Start by just defining a couple of libraries that we're going to use today. We're going to use a plot library, and we're going to use, well, maybe we're going to use NumPy, but it's always good to have NumPy. NumPy is the standard math package that is inside Python. So we can run these by either clicking on this button or we can copy them across here. Okay, so we'll start with the pitch. We're going to have a pitch which is, so it turns out StatsBomb use yards. Maybe that is a standard, I don't know. Anyway, so their pitches are 120 yards by 80 yards. I'll put that in there. That's our pitch length and our pitch size. Last time we decided we were going to analyze England versus Sweden in the Women's World Cup. It's me who decide what matches we're going to analyze, and that's the one we had a look at. And we found out the match ID for that was 69301. The next bit of code, it basically just loads all of the event data into the JSON file. I'll run that. So there's a load of stuff inside this data file when you've loaded it in. We'll just click on it up here. I always like to go into the Variable Explorer and find out what's going on up there. And it's got a whole range of different information. I'm not even going to manage to get into all of what's inside this file. It starts with details of the lineup and the formations and the players in the different positions. Then later on, we actually have the individual actions which we're going to be interested in. So this is a pass, for example. We have the recipient of the pass, and we have who took the pass, when it happened, and so on. So all of the information of all the events that happen on the ball are included inside this JSON file. It's maybe just worth pausing there to emphasize one thing about this data. So this is event data. This is passes, it's interceptions, it's shots, it's everything that happens with the ball. It's not the positions of the players when they don't have the ball. So every time a pass is made, the start coordinate is noted and the end coordinate is noted. Every time a shot is made, the coordinate the shot is taken from and where it landed up inside the frame of the goal or outside the goal. All of those types of things are noted, but not the positions of the players that don't have the ball unless they get the ball. So it's events on the ball, event data that we're talking about. And we're going to take two of those types of events, the shots and the passes, and we're going to investigate them. Afterwards, I'm going to give you an exercise. I'm going to give you actually the passes as an exercise, but I'm going to give you a further exercise where you can maybe look at interceptions, you can look at tackles and all of those other events. Those events are also in this data set. We're just not going to look at them in detail today, but certainly you should spend some time looking in detail after you finish going through this lecture. So the next lines here basically load in the data and get it in a form we can work with. It's always difficult, I think, when working with this type of thing to emphasize what is important and what's less important. I think the first parts of this particular lecture and the stuff I'm running now, that's not really the important parts. Where I really want you to start thinking and start working from is exactly this line here where we have a data frame of the shots. We've already loaded in the JSON file with all of the data, and this line here just identifies the shots, and that's what we're interested in plotting. Next step now is to plot the pitch. And here I'm going to use some code I created earlier, or I'm going to use some code that's adopted from FC Python with a few other alterations along the way. And it basically draws the pitch. So I've got a function which I import from FC Python, which draws the pitch like that. If you have a look inside the FC Python file, which is also on the GitHub, you can find that it's basically a series of plotting lines using the plot commands. It plots some circles, some semicircles, penalty spot, and so on, and creates the pitch there to any given dimension. Remember, the stats bomb dimension is 122 yards by 80 yards. So I've plotted the pitch. Now I'm going to go into the shots and I'm going to iterate through each of the shots and plot them one at a time. And that's what this for loop does. If I actually start by setting up so I can just look at one shot, and so if I just look at the first shot there, then we can actually find that if I run this, I have the x coordinates of the first shot. That's found in location. You can actually look inside the data. If we just look in the shot as a whole, see that there's a whole list of things. I type in shot and I get a whole list of things. And one of them, if you look it up, is location. And the first number in the location, I think I'll just start by doing that so you can see. Shot location has two coordinates, 104.7 yards and 45 yards. It's quite a central shot, a little bit out to the right. And then exactly what I put into X and Y is location 0 and location 1, which gives you the X coordinate, 104, and the Y coordinate of the shot. And that's basically what the loop goes through. It goes through and finds where the X coordinate of the shot is, where the Y coordinate is shot. It finds, was it a goal? And then it plots the shots, basically deciding, it also looks at which team it is. So if it was the home team or the away team, that's the team name here, and it plots them on alternative sides of the pitch. Now run this bit of code and you can see what comes out. So you might have noticed, if you're paying attention, that it's got a bit darker while I've been making this video. That's because I had to sort of break for my dinner, and then I've had all of these sorts of technical problems. But now I think I've got it sorted out. So what I'll do is I'll run the rest of the code. So we loop over every one of these shots and plot them out. I'll press run here. And I've now got my lovely shot map. Got the Sweden's goals and shots on the left-hand side, Aslani's goal here, Sofia Jakobsson's goal here. The other lighter blue, their shots which weren't goals. Then Frank Kirby's goal over here, and a few long-distance shots from England, few in the penalty area as well. Every circle is a shot, the darker shots are goals. I think the idea here, as usual, you should work through and have a look at what I'm doing here in order to do those plots. It's not that important you understand the details. What I want you to do is really get an overall idea of how this works. You basically loop over the shot data frame and you find the particular items you're interested in plotting, which of course are the X and Y coordinates on the pitch, whether it was a goal or not, the name of the goal scorer and the team that scored the goal. And then you can actually organize them and print them out in the way you want. So one extra thing I did is, since StatsBomb already have their own expected goals model, which basically gives you the probability of scoring a typical shot from that position, I also looked if I made the circle size, if I made the circle area proportional to the probability of scoring the shot. And that was done here. So instead of circle size 2, I make the circle size, the circle, which is the circle radius, proportional to the square root of the probability. And if the radius is proportional to the square root of the probability, then the area will be proportional. I had to think there. The area will be proportional to the probability itself. Okay, so let's run that one. And now we've got this. So the area of each of these circles is proportional to the probability of a typical chance from there being a goal. So the expected goals of those shots. So a couple of very good expected goals there for Sweden. And the actual goals themselves were a much lower expected goals. Aslani's goal seems to be estimated by the StatsBomb XG model a reasonably small chance, and Sofia Jakobsson's was even smaller. And the Kirby goal was actually bigger than both of them. But it was an even match. Both of the teams had some reasonably good chances in the match. As I've always been emphasizing in this course up to now, the only way to really learn any of this is to do it yourself. And so that's why the code is there on the GitHub. You download the code now and you play around, or hopefully you've been doing this while I've been talking. You download it and you play about it and do it yourself. And so I've got a little exercise for you to start with here. And what I thought is, instead of shots, what about if you make a data frame of the passes? So up here where I look at the shots, find all of the passes instead. That's step 1. Then step 2, plot the start point of every Sweden pass and allow Sweden to attack. Here I've got a Sweden attacking right to left, but as a kind of standard, and I'm not sure why it's a standard, teams, I think probably TV thing, you think of attack, anyway, you attack left to right. And so if you could plot all of the Sweden passes going left to right, then I thought you could, I have a soft spot for midfielders normally, and I thought that you could plot all of Caroline Seger's passes for that match. And then also, after you've plotted a circle, plot an arrow leading out of that pass, so you can actually see where it ends. So you need to know both the start location and the end location of the pass. So go away and have a go at that problem, pause the video, try and solve it, try and get as far as you can, and the answers are coming up in a few minutes. Okay, so how did it go? Right, here we go. I have got the code here. I commented it out before. I'll uncomment it and I'll run it. Okay, so the idea is basically the same as before. We're going to, first of all, you have to make the passes, and basically you need to change type name that you're interested in to pass instead of shot. Pretty straightforward. Then the next stage is, well, you iterate through the rows of all the passes that you've created. I think I said first here I've written the actual code for Caroline Seger. If we're interested in her passes, we can run this thing here. I'll just run it. And I have generated all of her passes during the match, playing all over midfield, actually. And if I was interested in all of the passes, then I just need to get rid of this if statement about Caroline Seger. And I can run it again. And we have, whoa, all of the passes that were made by Sweden during that match. Pretty messy stuff. I think that's probably why it's better if you just plot one player's passes at a time. Okay, I'll just extend that a little bit because I'm not going to upload this original code on the video on the GitHub. It will only be available in the video. So if you're interested in seeing exactly what I did to solve this problem, then have a look here. Right, and the last thing, it really is dark now. It's taken me a bit longer to record this video than I thought it would. It's getting quite dark. The last thing I am going to do is give you a bit of a challenge. So one thing, I've done 3 videos now, and I can call these 3 videos, they're the Python basics. And in order to get anywhere, you have to be able to do some programming in either in R or Python. There are other languages which you can use, but they're the 2 major languages for using. And I've given some basic ideas about how you use Python to interrogate data frames and to get information out of them. Really, it's up to you to practice, 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 because what I'm going to do in the next stages of the course, for my part, is I'm not going to look so much at the details of how we do the programming. I'm going to get much more into the conceptual issues about how we model football. How do we create a mathematical model of football? How do we use it to understand the game? And how do we use it to improve our performance as a team? So what I'm going to leave as an exercise for you is to do a little bit of playing around and understanding of football using the tools and the data that we've looked at for, up to now. If I go into here, and here's my homework then. So I'd like you to explain your opinion using data. So everybody who's into football saw at least one match at the World Cup. You probably saw a lot of them if you're so interested you're doing a football analytics course. So here's your homework. I'd like you to think of a player who you enjoyed watching at the recent men's or women's World Cups. And then think about what actions did they perform when they had the ball, and what was important and why. What did you tell your friends you thought was interesting about how these particular players play? So I really want this to be a question that's driven from your observations of watching football. How does this particular player play? And then go into the StatsBomb data, because there's both the men and the women's World Cups, plot the actions that you think are important and describe how the data supports or contradicts your analysis. And I think you should do this in a number of stages. I don't think that you should immediately draw the conclusions, but start plotting the different actions and start building up an understanding of how those actions relate to your own understanding. Because that's actually what we're going to be doing a lot when we're modeling football properly. Python's just going to be a tool, and the data is just going to be a tool to really building up an understanding of the game. So I want you to already start doing that now. Plot the actions and describe, plot the actions and think about how they relate to or contradict your own analysis of that particular player. You can, of course, take a team if you want to, but I was thinking a focus on a player might be quite nice. And then to complete the homework, write a carefully composed tweet, or it can just be 200 characters or 240 characters of Twitter, or just a short blog post using at most, okay, at most 2 figures to illustrate your point. And this is going to be really crucial when we come to using analytics inside clubs later. You normally can't write a massive, massive description of everything that's going on. What you have to do is you have to boil down your understanding and illustrate it with probably 1 figure is what you have. If you're going to talk to the coach about something, you have 1 figure to illustrate it. If you're going to talk to a player about it, you have 1 figure to tell them something. And so on, but I'm going to let you have 2 figures because you're just starting. So, but at most 2 figures to illustrate your point. And then share it with the hashtag FOT on Twitter, or you can put it into Discord to the other people who are following it. The Discord link is down at the bottom. I'll put it at the end of this video. And share it, and we'll see if we can get some feedback on it. If I see it, I'll try and give some feedback on it. And if other people are doing the course, they can also try and give some feedback on it. So that's your homework. Explain your own opinion with data. See you next time.